Perfect. Thank you. Um, so like Troy said, we have been using the SX12 quite a bit out on the projects we have for NDOT here in the Reno area. And I'm sure everybody at this point in the conference knows what the SX12 is. I took this straight from the internet, but collects millions of points. Per Joe's presentation, sounds like 26,600 per second. That's 600 meters, or about a distance, or 1,969 in freedom units. But for us, the biggest deal is we can get out there, scan efficiently. We can gather the data in locations that we can't access and get real rich data accurately. So my presentations really just kind of show some use cases we had throughout the project, some of the simpler stuff to more complex. And then if anybody has any questions, feel free to jump in. So using the SX12, kind of first thing is a little different than most of the scanners. It sets up like a total station. You'll resection in. That makes it a lot easier on the data management side. I guess I didn't give my background. I came from a construction company, and then I moved over to a data prep and management software or management company that did this for people, third party. And now I transitioned over to CME, who does construction management, then integrates in with the local agencies or whoever may need CM work. So currently with NDOT, we're going out here and having to collect all the data for the project that's ongoing. Bunch of different reasons, some being revisions, some pay estimate type work in order to track the quantities and any kind of design revisions. So this kind of look of an area off a bowl where an off ramp's coming off of the freeway. Some of the basic level stuff with the scanner, you can go out and just um, scan what's existing out there, and then you can come back in and scan, say next week, next month, these revisions, and continue to compare those surfaces to generate quantities. It's kind of example what it looks like, the area, what the scan would come out, and then we're using Trimble Business Center in order to clean up these scans and get out the vegetation, get this thing down to bare. It's something that's usable that we can then take and start quantifying in. So on these road projects with rough terrain, hard to access locations, it starts becoming extremely beneficial to use the scanning technology that you guys have. For an example here, this is a median in between a bridge, and we found out we had a change order on this work, and we'd have to go back out and collect what work had been done, and then how much we would have to remove in order to take it out. So in a scenario where you just had a scanner, sure, you can scan what you had, do the work, and then scan how much it's changed. But we'll get to this scenario a little later when the real power is using it with the model you have and able to run the scenarios and kind of estimate those quantities before you got to get out in the field and actually do the change order work to get it authorized, right? Some other aspects of the scanners just to get that real dense, rich data set. Here is an MSE backfill that's happening in between two bridges, soil nail walls on both sides. And the SX12 allows us to set up real quick. And in 30 minutes, we can scan this area and get that data back to the field, right? Or back to the office to process. And then we're using Trimble to extract all the scan data and then try to classify it. And that's what you're seeing in the different colors on the screen. There's, columns, equipment, walls. So you can't really tell much when you get to it, but when you get it down to ground and spin this thing around, you can pull out what usable data you have and then run the quantities versus the next week. Or if you have the model, you can run your remaining to complete what's behind the wall. Another big benefit that we have with scanning is just how much data is collected. This specific example and why I have it is we had to go back and tie into the bridge deck, and we had already excavated the roadway in that section, and we couldn't get that outside lane. So we were able to go back and review some of our old scan data and find it, extract it, and then add that back into the model so we can smooth out that transition and how we were going to tie in. So depending on the type of projects you're working on, most DOTs, you're going to get some kind of existing surface. Starting to be pretty common. So you can then use the scanner to verify, how are you coming in with some of your existing, what kind of quantity, potential discrepancies, anything else, go out and verify. Most of the time for heavy civil, it's not a big deal, but even a tenth off from aerial mapping, which is well within the tolerance of aerial mapping, still has big money consequences if we're off, right? So we were able to come in, collect some accurate data, and then realize we had to change a special median barrier rail going down the entire center of the freeway on this expansion. So being able to go out and accurately collect that data quickly and then get everybody else, the design team, on a revision and back out to the contractor before we had any delays was a great use case for the scanner. But where you really get your money was worth is when you start designing and I guess taking that whole design and transitioning it over into a model for the survey equipment, right? So you're going to go out in the field and you're going to have the complete project modeled so you can accurately lay it out for one, but two, when it comes to the scanner, is now you can accurately quantify and verify what's happening in the field, right? This is a slope. It would have been hard to access traditionally, already rip-wrapped. It would have taken our team a significant amount of time to go out and data collect the as-built on this and get final pay quantities out. We were able to go up on the hill, set the SX12 up, and in one shot, get the majority of the area that we needed, and then compare those quantities to design and make sure everything was the way it should have been. So another example of that, tying it into design, is from the aerial maps or maybe some of the existing information that you don't have enough to make any changes. So this is an interchange north of Reno here, all part of the same project. We had to change some of the layout on the slope, some of the drainage, and for temporary paving that was decided to remain in place instead of be put in for access and then tore out later. So kind of an on-the-fly redesign. We're able to get out there, collect the data, get it over to design, run some slope projections, change where some flow lines were ourselves, see how that all tied in, and get back out in the field and get the work done. Same thing, same area once it's cleaned up. In TBC, the scanning module makes it really nice to quickly and accurately remove a lot of that noise, so to speak, in the point cloud. And that's what some of that looked like from the model standpoint after we transitioned the slopes in and made sure we had, safety slopes required, enough distances coming off that ramp, and identify where we needed to put in rail. So to have that scanner to be able to go out and get that information quick always saves money. Same thing up here was top of an off ramp. We kind of ran out of our model. We didn't have accurate area. We had to tie in this ramp. Contractor was already building, so we were able to go out, scan this intersection, get the data that we needed, clean up that data, and then tie it into the model and change the profile of that ramp so it tied in properly. What we're doing on time. More use cases is in the main is just going out and getting quantities quick. And like they said earlier, not a lot of people, the workforce is down. We don't have the bodies to just go out and collect the data that we used to have. And that's where the scanners come in clutch for us, is to be able to go out and in 2 setups, we can catch a entire slope. We can verify what's remaining, where we're at, the quantities. We could run our cut fill maps, see if we overcut, undercut. We can process that data and then kick it out and do a deliverable that is, more user friendly for the remainder of the project team. Another example using the scanners, we had some slopes that were close to right of way by design, so we had to go back out and do another revision out in the field. This area, a lot of vegetation, would have been hard to collect the data. It's real steep slopes, traditionally with just a rover, and we knew we didn't have tight elevations and good accuracy from any kind of aerial mapping that potentially was done previously. So we were able to run out for the design team, scan the whole slope, pull out the vegetation, and then project our new slopes and see where we were going to tie out. So back to the median scan and kind of what it looks like. The ability with the SX12 to kind of window out what you need is extremely nice for us, because instead of just having to set a scanner up and let it run, we can just pick, hey, focus on the median. We get some of this data on the outside that's pretty easy to clean up, but it limits those scan times and field setups and how fast we can return that data back to the office. So we're back on this scenario with the change order. We had to get some information quick on a retaining wall that we were doing in the median. We were able to scan that